Hello friends, welcome to our channel Engineers Revolution. In this video, you will go through an example project end to end on how to predict a housing price using machine learning algorithm using the tools Python and Scikit-learn. There are many steps you will go through. How to get the data, how to discover and visualize the data to gain the insights, how to prepare the data for machine learning algorithms, how to select a model and train it, how to fine tune your model, how to present your solution, how to launch, monitor and maintain your systems. When you are learning about machine learning, it is best to actually experiment with real world data, not just artificial datasets. Fortunately, there are thousands of open datasets to choose from, ranging across all sorts of domains. In this video, we chose the California housing price datasets from the StatLib repository. This dataset was based on the data from the 1990s California census. It is not exactly the recent, but it has many qualities for learning, so we will pretend it as a recent data. It's time to get your hands dirty. Don't hesitate to pick your laptops and walk through the following codes I'm gonna mention further in this video. First, you will need to have Python installed. I have made a video on how to install Python. In that video, I would have installed Python outside the program files folder in the C drive, so that you need not set the environmental variable for Python, and also you will not be denied any permissions further. The link of that video is mentioned in the description. Do check it out. You will need a number of Python modules such as Jupyter, NumPy, Pandas, Matplotlib and Scikit-learn. If you haven't installed Jupyter yet, I have made a video on how to install Jupyter on Windows 10. The link of that video is mentioned in the description. Do check it out. Try to install all the required modules and the dependencies using simple pep command. In order to check your installation, try to import every modules like this. There should be no output and no error. Now you can fire up the Jupyter by typing Jupyter notebook. Let's now create a new folder within the desktop and rename it to ML project folder or something else, whatever you want. After typing in the name, click on the rename button. You can see the project folder has been created. Now create a new Python 3 notebook and rename it to ML notebook. You can see that the notebook has been created within our folder.
In typical environments, your data would be available in a relational database or some other common data store and spread across multiple tables or documents or files. To access it, you would first need to get your credentials and access authorizations, and familiarize yourself with the data schema. In this project, however, things are much simpler. You will just download a single compressed file, housing.tgz, which contains a CSV file called housing with all the data. You could use your web browser to download it, and run tarfile to decompress the file and extract the CSV file, but it is preferable to create a small function to do that. It is useful in particular if data changes regularly, as it allows you to write a small script that you can run whenever you need to fetch the latest data, or you can set up a scheduled job to do that automatically at regular intervals. Automating the process of fetching the data is also useful if you need to install the dataset on multiple machines. Here is the function to fetch the data. Now when you call fetch_housing_data, it creates a datasets/housing directory in your workspace, downloads the housing.tgz file, and extracts the housing.csv from it in this directory. Now let's load the data using pandas. Once again you should write a small function to load the data. This function returns a pandas data frame object containing all the data. Let's take a look at the top 5 rows using the data frames head method. Each row represents one district. There are 10 attributes: longitude, latitude, housing underscore median underscore age, total underscore rooms, total underscore bedrooms, population. Households, median underscore income, median underscore house underscore value, and ocean underscore proximity. The info method is useful to get a quick description of the data, in particular, the total number of rows and each attribute's type and number of not null values. There are 20,640 instances in the dataset, which means that it is fairly small by machine learning standards, but it's perfect to get started. Notice that the total underscore bedrooms attribute has only 20,433 not null values, meaning that 207 districts are missing this feature. We will need to take care of this later. All attributes are numerical, except the ocean underscore proximity field. Its type is object, so it could hold any kind of Python object, but since you loaded this data from a CSV file, you know that it must be a text attribute. When you looked at the top 5 rows, you probably noticed that the values in the ocean underscore proximity column were repetitive, which means that it is probably a categorical attribute. You can find out what categories exist and how many districts belong to each category by using their value underscore counts method. Let's look at the other fields. The describe method shows a summary of the numerical attributes. The count, mean, min, and max rows are self-explanatory. Note that the null values are ignored, so, for example, count of total underscore bedrooms is 20,433, not 20,640. The SDD row shows the standard deviation, which measures how dispersed the values are. The 25%, 50%, and 75% rows show the corresponding percentiles. A percentile indicates the value below which a given percentage of observations in a group of observations falls. For example, 25% of the districts have a housing underscore median underscore age lower than 18. While 50% are lower than 29, and 75% are lower than 37. Another quick way to get a feel of the type of data you are dealing with is to plot a histogram for each numerical attribute. A histogram shows the number of instances that have a given value range on the vertical and horizontal axis respectively. You can either plot this one attribute at a time, or you can call the hist method on the whole data set, and it will plot a histogram for each numerical attribute. The hist method relies on matplotlib, which in turn relies on a user-specified graphical backend to draw on your screen. So before you can plot anything, you need to specify which backend matplotlib should use. The simplest option is to use Jupyter magic command %matplotlib inline. This tells Jupyter to set up matplotlib, so it uses Jupyter's own backend. Plots are then rendered within the notebook itself. Hopefully you now have a better understanding of the kind of data you are dealing with. Okay guys, we had a good time on how to get data and how to visualize them. If you have any doubt until now, do mention it in the comment box, and also, do wait for the next video on how to create test set and train them. See you soon in the next video. Until then, it is bye from our team.